A developer working late asks their company's documentation assistant a simple question: how do I authenticate with the Payment Gateway API? The AI responds immediately with a complete OAuth 2.0 flow, exact endpoints, and perfect curl commands for version 3. The code is flawless and professional, but there is one problem. The company only has a version 2 in production. Version 3 exists only on a roadmap, yet the AI generated the implementation with absolute confidence. Large language models do not have a factual memory. When you ask a question, the model isn't looking up the answer in a database. It is simply predicting the next most statistically likely sequence of words based on patterns learned during training. If a consumer chatbot gets a recipe wrong, the stakes are low. But in finance or healthcare, models have been shown to hallucinate between 3 and 27% of the time. In these domains, a fabricated detail is a significant liability. You cannot fix this through prompt engineering alone. To stop hallucinations, engineers must architect systems that limit the model's reliance on its internal weights and force it to work from a curated window of verified information. The path forward isn't trying to build a smarter, flawless brain. It requires surrounding the model with an external architecture that enforces accuracy. Think of a standard AI as taking a closed book test. It only knows what it memorized months or years ago. The shift to Retrieval-Augmented Generation, or RAG, changes the rules to an open book test. With RAG, before generating a word, the AI searches a trusted database. It retrieves the verified document, then summarizes that context. This differs from fine-tuning, where the model absorbs data into its internal weights, rather than using an external lookup for real-time verification. But an open book is only useful if the pages are accurate. In one case study, an HR bot answered a question about maternity leave. It retrieved a document and confidently enforced an 8-week policy, missing the fact that the company had updated to 16 weeks a year prior. The AI accurately summarized the document it was given, but the database contained an outdated draft. This highlights the core challenge. Building a reliable AI is a data supply chain problem. Garbage in equals garbage out. That supply chain begins with data extraction. When companies scrape standard PDFs, the process often destroys crucial context, turning complex tables and formatted lists into an unreadable wall of text. Reliability requires data to be formatted in Semantic HTML or Markdown. This preserves the structural hierarchy of headers and lists, allowing the machine to parse how the information is actually organized. AI systems ingest information in discrete, isolated blocks called chunks. If a critical exception gets separated from the rule during chunking, the AI misses the connection. To prevent this, documentation must be rewritten so related facts stay together, ensuring any self-contained chunk remains accurate. Even with high-quality data, an AI may still encounter a query it cannot resolve with certainty. This is where corrective RAG systems provide a final safety net. These systems evaluate the generated response against the source documents in real time. If the confidence score falls below a specific threshold, the system halts the response and triggers an intervention. In many enterprise setups, that intervention is a human-in-the-loop fallback. Instead of allowing the AI to guess, the system automatically routes the low-confidence query to a live customer service agent. For high-liability areas, engineers implement keyword blockers. If a user asks a question involving legal compliance or medical determinations, the AI is completely prevented from generating a response, directing the user to a human expert instead. Combining structured data, semantic chunking, and human guardrails creates a repeatable framework for deploying generative AI in high-stakes environments. The results of these combined strategies are quantifiable. Organizations that move beyond simple prompts and adopt these architectures see their hallucination rates drop from over 30% to under 5%. This marks a turn in how we manage information. For 20 years, we formatted websites for Google search. Now, the work is formatting human knowledge so that machines can reliably retrieve and interpret it. High-stakes industries are increasingly moving away from massive, generic models in favor of small language models. These smaller systems operate securely within highly curated data ecosystems, where accuracy is easier to verify. Ultimately, the quality of an artificial intelligence is bound to the hygiene of the information we provide and the human partnership that oversees its performance.